As part of her training, Alexina rows 15 kilometers down Lac Saint Louis with the current and then rows back against the current. She rows with the current to the Lachine Rowing Club, where Tori trains. Alexina rows 15 kilometers downstream in 1 hour and 30 minutes. When she turns around and rows back to the Beaconsfield Rowing Club against the current, it takes her 2 hours and 30 minutes. Okay, Alexina calculates her speed and the speed of the current in kilometers per hour and enters these rates in her training diary. Okay, so I'm going to calculate her speed and the speed of the current. Okay, so I'm going to say let x be Alexina's rowing speed and let y be the current speed. Okay, so we know that velocity times time, or speed times time, is distance. All right, we know the distance is 15 kilometers. So I'm saying times velocity, or velocity times time, doesn't matter which, is equal to distance. And so we know that the time it takes for her to get down the stream with the current takes an hour and a half. Okay, so 1.5 hours. Or you can turn it into minutes, which is 90 minutes. Okay, so 1.5 times x plus y, and this is with the current. And then against the current, it takes her 2.5 hours. So 2.5 times x take away y, right? Because in this case, it's her speed take away the speed of the current, all right? So 2.5 times x minus 15 is equal to the same distance. So when she's with the current, it takes her 1.5 hours. When she's against the current, it takes her 2.5 hours. So this is against the current. All right, so this is going to give us our two simultaneous equations. So we have 1.5 times x plus y is equal to 15. I'm just going to, well, you could divide both sides by 1.5. And that gives us x plus y is equal to 10. Okay, or x is equal to 10 minus y. And then if I take my other equation, and if I take my other equation, we have 2.5 times x minus y is equal to 15. And I'm going to replace the x with 10 minus y. Yeah, first I'm going to get rid of the 2.5. So I have x minus y is equal to 6. Replace the x with 10 minus y. I have 10 minus y again equals 6. That's 10 minus 2y is equal to 6. I'm going to subtract the 10 from both sides. And so that's going to give you negative 2y is equal to negative 4. Divide both sides by negative 2. And that's going to give us y is equal to positive 2. Okay, so the current is 2 kilometers an hour. And Alexina's rowing speed is, have we figured out x yet? We haven't. So let's go to, we have it right here. So x is equal to 10 minus y, and y is 2, so 10 take away 2 is going to be 8. Okay, so x is equal to 10 minus 2, which is going to be 8. Okay, so that tells us that Alexina's rowing speed is 8 kilometers an hour, and the current speed is 2 kilometers per hour. Okay. The next step, we were told that Tori also wants a spot on the McGill crew. Tori's rowing speed just happens to be identical to Alexina's. Tori and Alexina both start rowing at 6 a.m. Tori rows against the current from the Lachine Rowing Club, while Alexina rows with the current from the Beaconsfield Rowing Club. When they meet, Alexina and Tori both wave and promise to get together for a latte. When and at what distance from the Beaconsfield Rowing Club do the two girls meet? Please indicate this point on the map below. Okay, so I'm going to say let t be the time that Alexina rowed, and d is going to be the distance that she rowed. Okay, and notice that the time that Alexina rows is equal to the time that Tori rowed. They both start at 6 a.m. and they both meet at the same time. Okay, so that t is going to be the same for the time that Alexina rowed and the time that Tori rowed. Okay, d is the distance that Alexina rowed, and if they, all together, like let's say they met, I don't know, right here. This is where I live. Where do I live? Somewhere in here. So let's say I live right there, okay, and they met right outside my house, right there. Okay, so let's say one of them rowed 11 kilometers, and that would mean that the other person rowed 4 kilometers. Does that make sense? Okay, that doesn't look like 11 kilometers. If one person rowed, I don't know, 8 kilometers and the other person rowed 7. Does that make sense? Okay, because altogether, we know no matter where they meet here, like if the first person rowed only 2 kilometers, the other person would have to have rowed, to meet her, would have had to have rowed the rest of it, the 13 kilometers. Okay, so d is the distance that Alexina rowed, and if we say that, then Tori had to have rowed 15 take away d. Okay, so we know that time times velocity is distance. So time times, now the velocity of Alexina rowing with the current is going to be 8 plus 2, like her speed and the current speed, so that's 10. Okay, so this is with the current. And then for Tori, it's going to be t times 8 minus 2 is 15 minus d. which is going to be against the current. Okay, so this is going to give us 8 plus 2 is 10 times t is 10t is equal to the distance. Okay, and here we're going to get 8 take away 2 is 6, so 6t is equal to 15 minus d. Alright, so we have two equations, two simultaneous equations, and we know that d is equal to 10t, so I'm going to replace it into this equation. So I'm replacing d with 10t. So we have 6t is equal to 15 minus 10t. I'm going to add 10t to both sides, and that's going to give us 16t is equal to 15. Divide both sides by 16, and that gives us t is equal to 15/16. And remember, our time is in hours, so this is 15/16 of an hour. So not quite an hour. Okay, to figure out how many minutes that is, that's 15/16 of a whole hour. So 15/16 of 60 minutes, right? So we're going to do, oh yeah, I'm also going to figure out the distance, by the way. So the distance is going to be 10 times t, and the t is 15/16, so 10 times 15/16 is going to give us 9.375 kilometers. Okay, so that's the distance that Alexina rode. Okay? Okay, so then to figure out what fraction of a minute, sorry, of how many minutes we have that fraction of 60 minutes, which is that fraction of an hour. Okay, so 15/16 times 60 is going to give us 56.25 minutes. Okay, now that 0.25 minutes, that's a quarter of 60 seconds. That's 0.25 of 60 seconds, which is 15 seconds. So it's 56 minutes plus 0.25 of 60 seconds, which is going to be 56 minutes, 15 seconds. Okay, all right. So the next part is we know that she traveled 9.375 kilometers from this point. Okay, now where do we find that on the map? We can kind of estimate, but we want to get it exact. All right, so what we're going to do is we're going to measure how far this is. Okay, now let's go back. So using my handy-dandy ruler, we're kind of zooming in here. So this is 17.7 centimeters. Okay, approximately. So I'm saying that this 15 kilometers on the map is equal to 17.7 centimeters on the drawing. Okay, and this is the new. So we're like the drawing is always the new. You know, the actual, the actual land is old because it's older than the map. Okay, so we have new over old. That's your ratio of similarity. So 17.7 centimeters to 15 kilometers, that's new over old, is equal to whatever this distance is in centimeters compared to 9.375 kilometers. Okay, so we want to figure out how many centimeters it is for these kilometers. So I'm using my similarity ratio. I'm going to cross multiply the 9.375 times the 17.7, divide that by 15, and that gives me 11.0625. Okay, now we're using a ruler, and a ruler is pretty accurate to the nearest millimeter, so that's like 11.1 centimeters. Okay, now they're saying 11.06, but really, can you be that accurate? A little bit more than a millimeter, so it's about there. Okay, so you want to get, I was about to say you want to zoom in, but you can't zoom in with a ruler, but there you go. Okay, so that's where they met, and this is where I live, by the way. Okay, and that's it for the whole ES. Have a good day. Oh, and this is what a latte looks like, in case you're wondering.